Okay, guys, welcome back to my channel. This is another example, still talking about surface areas and volumes of solid shape. Let's take a look at this example and solve it and see what this looks like. Okay, we have a bucket which is 20 centimeters in diameter at the top and the 14 centimeters in diameter at the bottom, 15 centimeters deep as well. We want to calculate the capacity of the bucket in liters. Okay, so we're going to look at a sketch of how a bucket looks like. So let me start my solution from here. Let me quickly see how I can quickly simulate how a bucket looks like. So I'm sure we can relate with this. Okay. And then we need to bend it a little bit. And try to see if I can maintain. It's just a sketch. Need to bend it a little bit. Okay. To form a bucket. And we know that at the bottom of the bucket, we also have, okay, we have it to be circular like this as well. Now this bucket is 20 centimeters in diameter at the top. So that simply means from here, diameter at the top, up to this place is given as 20 centimeters. Okay. I can easily come out of the shape to show that so that I don't make the shape too congested with my diagrams. But I can do this to show that from here to here is given as 20 centimeters. Likewise, the diameter of the bottom is 14 centimeters. So which means from here, following my broken line here to here is 14 centimeters. So I could also come out of the shape and do this to show that from here to here is given as 14 centimeters. This bucket is also 15 centimeters deep. So that is actually talking about the height. So allow me to do this outside the shape to show us that this is the depth of the bucket, which is given as 15 centimeters. Remember, questions like this, you will be the one to draw the diagram yourself. So I'm showing you how that is being done in this sketch. Now, the next thing to do is quickly identify that the top of the bucket and the bottom of the bucket will have their centers so that half of it is radius, half of diameter is radius, so that you know that this is 10 centimeters for the radius of the top, and then this is 7 centimeters for the radius of the bottom. Very important. Also, you can quickly include the depth of the bucket inside it, showing that that is also 15 centimeters. Noted. Okay. Before we proceed, we want to find the capacity of the bucket. The capacity of the bucket is equal to the volume of the bucket in liters. Okay, so let's take a note of that very quickly to tell ourselves that capacity, so we are solving question A now, capacity of bucket is simply equal to volume. Take that again. Volume of bucket in liters. Volume of bucket in liters. So we can write that down. It's equal to the volume in liters. You know you can calculate volume in centimeter cubed, but once you convert centimeter cubed to liters, you're already talking about capacity. So in other words, what we are really looking for is to find the volume of the frustum of a cone. I'm sure we can remember that from our previous lessons. The frustum of a cone definitely is going to be, the volume is going to be volume of the bigger cone when we bring it out, minus the volume of the smaller cone. You'll be wondering, where exactly is the bigger cone and where exactly is the smaller cone? Let me show you that very quickly. Okay, I'd like to adjust and write the rest of the formula just on the same line with it. Once I do that, I'm going to have this immediately. So I have minus volume of smaller cone. Now, the implication of what we are saying is simple. We are simply saying that if we decide to complete this cone, we continue it to make it a cone, and then we do the same thing here. We're going to discover what you are seeing right now. And what we are discovering is simple. Looking at this is a cone, but it is turned upside down. If you turn it around, you can see the cone appropriately. So there are two cones here, the big one and the small one. The small one is the one with the blue marker. So combining that with the frustum of the cone gives you the bigger cone. So I'm going to do a little bit of representation of all the sides that we have involved in this shape. For instance, I'm going to use small letter h to represent the height of the small cone here. I'm going to use small letter L to represent the slant height of the small cone here. Also permit me to do this as well. Let me use the green marker for that. Over here, from here, straight down to here. We're going to consider that as the height. But of course, not just any height, but the entire height of the bigger cone. So I can consider this as big H, for the big height, the height of the bigger cone. Okay? Also, permit me to also represent the entire length, slant height, L here, of the bigger cone as big L. So I can easily show that maybe on the other side here. So let me just quickly remove this guy here so that I can show the big L. I've already written 15 centimeters here for the depth of that, so no big deal. So for here now, I'm going to have, I'll still use the green marker for that so that it shows a replica of the dimensions we are trying to show. So from here to here, you identify that there's a slant height for the big cone, which you can call the big L. There's a slant height for the small cone, which was a small L before. And we can consider the radius of the big circle as big R and the radius of the small circle as small r, just to follow with that representation. Now, the volume of the frustum of cone, so let me just add of cone, is simply given as, returning to that, volume of cone is actually 1/3 pi r squared h. Okay? But because you know you are dealing with two different types of volumes, which is the big one and the small one, it will help to write it, okay, it will help to write it using the letters. So 1 over 3 pi big R squared big H to show for the bigger cone, and then minus 1 over 3 pi small r squared small h for the smaller cone. Well, to make the work easier, we can simply factorize 1 over 3 pi, which is common, and then have big R squared h minus small r squared h. Big R and small r, we know them. Big H and small h, we don't know them. So the first thing to do is to calculate the big height to proceed. So to find h, so that is big H now. To find big H, what do? You realize that from the diagram, big H is actually equal to small h plus 15 centimeters. Take a look at that from the diagram. Big H is everything here. So small h plus 15 should give the entire big H, the big height of the big cone. So calculating small h is our job now. Okay, and how do we calculate small h? So I will also say that to find small h is the next thing now. You recall from previous lessons that you have dealt with similar triangles and how to work out the ratio between corresponding sides of similar triangles. So based on that, you should be able to figure out that h plus 15 centimeters divided by h, that's the ratio for your height, h over h plus 15, or h plus 15 over h, big over small, should be equal to 10 centimeters over 7 centimeters, big radius over small radius as well. You can take a look back at our lessons concerning similar triangles. You quickly recall what we are doing here. So when we cross multiply, we're going to have 10h to be equal to 7 multiplied by h plus 15 after cross multiplication. I'll take that again. Okay. After cross multiplying, so 10h is therefore equal to 7h plus, that should be, that should be 105. So to conclude on small h, you collect like terms. When you collect like terms, you're going to have 10h minus 7h to be equal to 105. So when you do that subtraction, you're going to have 10h minus 7h equals 105. Okay. So expectedly, we have 3h equals to 105. And that shows that the height is equal to 105 divided by 3. Okay. All right. And when you divide that, you're going to have 35 centimeters for the small height of the cone. So remember that what we did over there was just to find the sketch that we have here is just a sketch, but now you see that normally this part of the small cone should have been longer than this part, but then calculations has been able to show us that from our sketch. Okay, so let's proceed. We have small h, we need the capital H. So therefore, conclusively, the capital H, therefore, big H, is going to be equal to h plus 15, small h plus 15 centimeters. So that means I have big H to be equal to 35 centimeters plus 15 centimeters. And when you add that up, you simply get that to be equal to 50 centimeters for the big H. So with the value of big H and small h, we cannot conclude on our answer for the volume of the frustum of the cone. Okay, let's quickly complete that. So coming here now to complete the solution. So from here, I'm coming back up here to have that now to be equal to volume equals 1/3 pi into the bracket of r squared h. Big R is 10, so that is 10 squared times the big H, which is 50, okay, minus small r squared, which is 7 squared, times the small h, which is 35, okay, close the bracket. So perform all this calculation, you'll be able to end up to have the volume of your frustum, that is the bucket. So this is 1/3. We might want to just maybe use 22/7. I'm not sure if we're given the value of pi in the question to use. So let's see. No, we're not given in the question. So we can use 22/7 for the value of pi here. So to complete the solution, we're going to have the following calculations. So I have this into the bracket of 10 squared times 50. And if I do that, I'm going to have all those calculations in there to simply give me 3285. That means when you do the calculation of everything inside this bracket, you get this. So this is going to be equal to the final answer when you complete it as 3,441 centimeter cubed as my answer there. Remember, what we are looking for is capacity, not just volume. Capacity means volume as well, but volume in liters is your capacity. So therefore, you can then conclude that the capacity of your bucket, which is the frustum of the cone, as explained earlier on, is then going to be equal to your volume, 3,441 centimeter cube. But of course, instead of writing centimeter cube, just write divided by 1,000 to convert it to liters. And that gives a final answer of 3.441 liters, which you can approximate to 3.44 liters. And this has been done to 3 significant figures, or you can also say to 2 decimal places. You're good to go. So guys, for question A of this example, that would be the correct answer. But mind you, we're not done. There are 2 questions in here. One is to calculate the capacity of the bucket. The other is to calculate, let's check it. Let's check what we have for the second part of the question. That's the B part. For the B part, we are to find what? The curved surface area of the bucket. The curved surface area of the bucket. So I'm going to come to this part of the board to solve question B. The curved surface area of the bucket. Let us remind ourselves that the curved surface area of a cone, okay, curved surface area of cone, let's put that down very quickly. Curved surface area of cone is simply given as pi RL, where L is the slant height of the cone. But because what we need is the curved surface area of the bucket, just like we did that of the volume. The curved surface area of the bucket, pardon me, let me use a short form for my curved surface area. So I'd like to use CSA to represent my curved surface area, okay? Curved surface area of bucket now, which is what we are looking for, the bucket, is going to be equal to the curved surface area of the bigger cone, just like we did for volume, minus the curved surface area of smaller cone. So to get that, it is a good way to say pi r, in fact, pi big RL minus pi small rl. Pi big RL is the curved surface area. That means big R, big L is the curved surface area for the bigger cone. Pi small r, small l is the curved surface area for the smaller cone. So let's find out. Do we know big L? Do we know small l? The answer is no. Come to the diagram. This is small l, and the entire here is your big L. Okay? So because we don't know that, we need to calculate them. First of all, let us calculate the small l. To calculate the small l, I would like to quickly include representations of the points around the diagram. Let me use a different color this time around. I think I'll go with red. So let me call this, so follow my letters, please, so that you know the triangles I'm picking on. If I call this maybe A, let me call this one B, and let me call this C. So this can be D, and this can be E, and I can call this F over here, and probably this one G. So now, I need to find big L and small l. Big L and small l, okay? Let's follow through with the formulas now. I will start from triangle CBD. Triangle CBD is a right angle triangle, as seen in the diagram. It's a right angle triangle as seen in the diagram. So putting this up to show you that diagram in my shape, this is what I have. You will see that this is CBD here, a right angle triangle. Okay, this is it right here, a right angle triangle. So if I bring out that triangle just for clarity purpose, what I'm going to have is this. A right angle triangle that looks like this. Such that this is the height of the triangle over here. Don't forget that it's right angled. So that means I have this to be my small h. This is the slant height L, small l. And definitely from the diagram, this is 7 centimeters. You can recall that the h, which is the small h, has been calculated before, and we got it as 35 centimeters. So by Pythagoras theorem, we can actually find small l, which is the hypotenuse here now. So you will agree that L squared should be equal to 35 squared plus 7 squared. So that L, small l now, is going to be the square root of 35 squared plus 7 squared. Okay, so doing that, you are going to have 35 squared plus 7 squared to simply give you, okay, 1225 plus 49. So you expect that to land you on the square root of 1274. Taking that square root, we're going to have 35.69 centimeters. That's for small l now. For big L, we have another triangle to focus on. So we're going to take it from triangle, okay? We're going to take it from triangle, that's the big triangle now. Triangle ACE. I'm going to draw it out. Triangle ACE, okay? Now that triangle ACE, if you follow through with the diagram, you will see it this way. Okay? 10, and then you have H plus 15, which is the big L. So this is how the triangle looks like. So let's sketch that out for the second triangle. It's a little bit bigger and longer than the previous one. So what you have is, this is going to be the big L, while this is, no, pardon me, the big L is here. This is the big L, the slant height. But this is the big H, which is the big height. Remember I said our focus is triangle ACE. So this is C, this is A, and this is E. So focus on that. Okay, this was CBD before anyway. So the radius here was 10 centimeters. And then we already calculated the big H as 50 centimeters before. Okay, so let me demarcate this so that it is clear and we are not mixing them together. So conclusively, we need to calculate big L. By Pythagoras theorem again, you will see that big L squared is going to be equal to 50 squared plus 10 squared. And that gives us 50 squared plus 10 squared. And then we later take the square root to find the value of big L. So to get 50 squared, we're going to have 2,500, which is 2,500, plus 100 for 10 squared. So we're looking at L to definitely be equal to 2,600, which means that big L, square root of 2,600. And that easily gives the square root of 2,600 is going to give us 50.99, 50.99 centimeters. Finally, going back here, finally, therefore, curved surface area of buckets will therefore be equal to pi. Of course, I can factorize pi out from the formula here, right here. Pi is common, into big R, big L, minus small r, small l. So let's substitute our values. This will be pi into the bracket of, what is big R? Our big radius is what? That is 10. Big L, let me write the big L very well. Big L is 50.99. Then minus small r, 7 centimeters, times small l, calculated as 35.69 centimeters. So calculating all of this and also multiplying by the value of pi in front of the bracket there, we're simply going to have that to be equal to 22/7 multiplied by the solution of what you have inside that bracket. 50.99 multiplied by 10 is going to give you 509.9. Okay, and that is going to give us in bracket 509.9 minus 35.69 multiplied by 7, and that should give you 249.83. So this simply gives 22/7 multiplied by 260.07. The conclusive answer from that is going to give us 817.363. 817.363. And that would be in centimeters squared, because we are dealing with area this time around and not volume. So approximately, we have the answer, which is the final answer here, to be 817 centimeter squared. And you can have that to 3 significant figures. And that is that, guys. So at the end of this example, we have been able to calculate correctly and accurately the curved surface area of the bucket, and we also did calculate the volume or capacity of the bucket as well. On this side of the board, we have it right here. So, and that is how that goes. So ensure that you take out time to write out all your solutions appropriately. I'm sure you've been doing that alongside with the video when we're solving this problem. Quite interesting, quite very explanatory. Okay, so I have another example coming next, which is going to be from the same topic. So please stay tuned. I'll see you in the next video. See you guys. All right.